Hello and welcome to this tutorial lesson on scanning. So what will we be doing during this lesson? Let's take a look. So first thing we want to do is we're going to look at 4 tools during this lesson. First tool is Nmap, where we will be doing a whole bunch of different scans and looking at the outputs of each scan. We'll also take a very brief look at HPing, at NICTO, which is a web scanner, and at NS lookup for DNS enumeration. Okay, but before we get going, let's just take a look once again at the Kali Linux tools listing. So, as you know, footprinting and scanning are all part of the information gathering phase, and here are all the information gathering tools. So as you can see, there's quite a few, and we're just going to literally touch on a few, the ones that I found the most useful in my experience. Okay, so let's get started with Nmap. To launch Nmap, we go to the terminal. Let's just make that a full screen so we can get a good view. And you literally just type Nmap at the prompt and hit enter. And as per the footprinting video, just a quick recap, you can see Nmap has got hundreds of different options that you can set. And there are entire courses and books written on Nmap. Today we're going to look at a few of the default scans in Nmap, but just quickly let's go through these help options here. Okay, so as you can see, there's different ways to specify a target, there's different ways to do a host discovery, there are different scan techniques, and this is what we'll be focusing on today since we're doing scan. And then further down you can see there are ways to specify ports, some service detection, there's the scripting part of Nmap, OS detection, which we'll also discuss today. You can also set timing and performance, as well as firewall, IDS evasion and spoofing, and then different forms of outputs. Okay, so let's get started. So the first scan we want to do is a ping sweep. If you recall from the theoretical part of this module, the scanning phase always has 3 parts: ping sweep, port scan, banner grab. Okay, so I've got a lab set up here, and we are going to do a basic ping sweep of the network just to see what is out there. Okay, so the command is nmap space -sn. So let's take a look at that. Okay, let's clear the screen, start at the beginning, and it is nmap space minus lowercase s lowercase n, and then the IP range. Okay, so I've got a small network setup, so my network range would be 192.168.1.0 to 255. Let's see what that brings back. Great. As you can see, that was rather quick. I mean, it scanned 256 IP addresses and found 8 hosts on this network. So, very briefly, the ping sweep with no other option set will give you a list of IPs that are live, as well as their MAC addresses. So, which is quite useful because you can already start ascertaining what sort of services are running. So as we can see at 1.1, we've got a Huawei Technologies. That's more than likely a router, which it is. We've got 1.12, we've got something running on Intel, so that could very well be a physical machine. At 1.23, we've got a Microsoft MAC address, and we've got another 2 down here. So those could most likely be virtual machines running Microsoft software. And we've got a 102, which is an unknown, but we've also picked up an Apple device at 103. Great. Here's a small tip. If you ever want to get a lot more information out of Nmap, all you have to do is in your command put a minus and then double V for extra verbosity. And the nice thing about double V is it'll give you an update as the scan is running. So but this scan's quite quick, so you'll see a lot of information fly by, but on longer scans like a UDP scan, which takes an inordinate amount of time, it does help to have a little bit of verbosity so you know what's going on in the background. Let's quickly run that and see what happens. Great. As you can see, a lot more information, but it did give us the few that we did find before. What it did give us is every other IP, and that it did not receive a response, so we know for sure that the ping sweep did in fact run. Obviously, for documentation purposes, I would recommend that you not use the extra verbosity, but it is always a nice thing to know what's happening in the background. Alright, let's clear that screen again, and let's move on to the next scan, which is a full scan. So a full scan is, if you recall from the TCP IP lesson that you may have attended in the past, is a full handshake, a three-way handshake of TCP. So from an IDS and firewall point of view, this will be picked up because you are making a complete connection to each IP address. But it does give you a lot of information. So let's take a look at that. Alright, so the command for a full scan, let's just clear the screen again, is mmap and then minus lowercase s, sorry, no space there, lowercase s, capital T, and let's put in that same range, .1.0-255. Okay, so the full scan has completed. As you can see, it took 32.24 seconds. And let's see what it brought back. As you can see, it brought back all those IPs that we found in the ping sweep, but it also gave us a whole bunch of TCP ports that are open filtered for each one. So if we look at the router, it's got FTP open, SSH, Telnet, HTTP, HTTPS, etc. Our physical machine looks like it's running some sort of Microsoft, which it definitely is. But as you can see, it's got RDP open, which is interesting. Our virtual machine is running Microsoft Directory services, so it's obviously has Active Directory or Active Directory Federation services running. Then let's look at the next one, which is 102, which is an Apple device, but no ports were found open. 103 is got a whole host of interesting stuff open, so it's got FTP open, SSH, Telnet, SMTP, etc., as well as PostgreSQL, VNC. So this would be a very interesting target to attack, first because it has quite a few protocols that you can remote into. Then finally, 104 was another Microsoft device, Microsoft virtual machine that's also all filtered. And then 105 had 111 TCP open, which is more than likely some form of Linux virtual machine. Great, so that is the TCP full handshake scan. Now let's quickly do a stealth scan. So the difference between a TCP full scan and a stealth scan is that the stealth scan does not complete the three-way handshake, which in theory is a little less stealthy than the full handshake. However, modern IDSs can pick it up. And if you're going to be anonymizing your scans with Tor or proxy chains, you will need to do a full TCP handshake, because the stealth scan does not work through the proxies or proxy chains. Okay, let's quickly clear the screen, and then the command for a stealth scan is nmap minus lowercase s, capital S, and let's put that IP range in again, 1.0-255, and let's run it. Okay, so the stealth scan is finished. As you can see, it took 38 seconds, which is a little bit longer than the TCP scan, full handshake scan, but this is running over a Wi-Fi network over here, so it's more than likely could be some contention issues. Okay, but if you look carefully, and you can do this on your own network, you'll see that the stealth scan actually brought back pretty much everything that the full handshake scan did. So in this instance, the stealth scan worked just as well. And as mentioned, it is more stealthy than the full handshake scan. But the caveat, once again, if you're going to be using proxy chains to anonymize your traffic, you cannot use a stealth scan. It doesn't work through that. You'll need to use the full handshake scan. Okay, so we've done a ping sweep, we've done a port scan. The next port scan I'd like to show you is a UDP scan, because there are two protocols on layer 4, as you know, that we mentioned in the theory part of this module. There's TCP, which you've done now, and there's UDP. So we need to definitely scan UDP because it hasn't been touched yet. So let's quickly do a UDP scan. So the command for a UDP scan is nmap minus lowercase s capital U, and then the IP range 1.0.2.255. Let that run a while. The UDP scan definitely takes a lot longer than normal TCP scan. Okay, so the UDP scan has now completed, and as you can see, it took much longer than a TCP scan. That's because UDP is a broadcast framework and pretty much broadcasting packets all over the network, so it's very noisy, but it's actually a very important scan to do, because otherwise you might be missing some important information. Let's take a quick look at all the UDP information it got. Okay, so on 1.1, which is the route, it found DHCP, which is obviously a UDP protocol, and 53, obviously DNS. It also found NetBIOS on our 1.12, and some other interesting things. It found an ISA KMP on our ADFS box, as well as some NTP traffic flowing. Also found NTP on 102. On 103, which is our very vulnerable box, it also found domain or DNS, it found DHCP, also found some NetBIOS for running, as well as on the 105 it found 68 DHCP running. So as you can see, UDP is actually quite useful, or the UDP scan rather, because otherwise you would have missed a lot of these open ports. Alright, so now that we've done the ping sweep and port scan, both TCP and UDP, let's quickly do the next phase, which is banner grab. And in nmap, let's just clear the screen, we use the OS detection to do that. So the command is nmap minus capital O, and then the IP range 192.168.1.0 and 2255. Okay, so the OS detection scan has completed, and as you can see, it does it in conjunction with a synth scan, but it does add this little bit at the end. So if you quickly go through the results, it checks the open ports like it does for TCP normally, but it also adds a little bit of guessing. So on our router, it's running a Linux kernel 2.6. On our 1.12 box, it's definitely running Windows Server 2012 R2 update 1, or any of these others, but I can tell you that that is definitely the OS that's running on that server. On this server, it's running 2012 R2, so that's also been picked up. On 1.101, it's an Apple device. It didn't pick up any OS running, or couldn't identify it, but if you look carefully, it's got TCP 62078 open, which is iPhone sync. So it's probably running some version of iOS, because it is obviously an Apple iPhone. Then further down, 102, too many fingerprints to match, and that does happen from time to time, so it just couldn't identify what 102 is. 103, which is a very vulnerable box, you can see it's got a Microsoft MAC address. However, the OS picked up that it's actually running a Linux kernel. And then on 104, again, too many fingerprints match this host to give it specific OS details. And then finally, in 105, it found it's running some form of Linux. So as you can see, we've done the ping sweep, the port scan, and the banner grab. There are a few other scans in nmap that you can test, and these are obviously listed here. There's the Christmas scan, the Fin scan, the null scan. ping scan, a UDP scan that we've done. And you do these to set different flags on your TCP packet and see the results that are coming out. What I can tell you is that these 3 scans return 0 results from any Windows operating system, but they do find some interesting stuff on Linux. So it is definitely worthwhile doing them as part of your penetration test. Okay, so that pretty much sums up and completes Nmap, or the scanning phase of Nmap, for this video. Now let's move on. Okay, I quickly want to talk about hping. So hping is on Kali as well. You launch it by typing hping3, but if you just type that, you're just going to get a prompt, which doesn't help much. So to actually find out all the different flags on hping, you actually have to type hping3 minus lowercase h, and that gives you all of the facts and all the flags that come with it. So hping is quite useful. It's sort of like a ping command, but it's a little bit much more than that. It does trace routing, it can do port scanning, and pretty much like Nmap, but I prefer Nmap personally. What hping is very useful for is setting flags. So you can actually craft your packet to the nth degree, and you do that in this section over here. So you can set all the different flags that come on the TCP protocol, and then see the response you get from every single device. And that's pretty much how a lot of fingerprinting is done down the line. In other words, trying to figure out what device is on the end of that IP address. Okay, so hping is very similar to Nmap, so I'm not going to go into any demo of it, but I just wanted to cover it with you. The next tool I quickly want to cover before we close off is Nikto. So Nikto is a web vulnerability scanner, and it's literally spelled Nikto. You hit enter, and then you get all the different flags that you can set for it. As you can see, there's an error because it didn't specify host. So I'm going to specify host quickly and just show you the output. So it's Nikto minus host, and let's do that vulnerable 103 server and see what it comes back with. Okay, Nikto has completed, and as you can see, it took 72 seconds to scan that server. And if you just quickly scroll through the results, you can see the kind of thing that Nikto will tell you. It tells you that there's an anti-click checking X-frame option is not present. There's no cross-site scripting protection set. There's a whole bunch of vulnerabilities, and the vulnerability numbers are listed. So it's actually quite a nice tool, and a very generic web scanning tool, which does help a lot. So you can see, and you can literally look at all these vulnerabilities and then use them to gain access down the line. So what's really interesting here is that it's actually found a PHP MyAdmin, which is used for managing MySQL, and that's totally open on the network. So it's very easy for someone to pretty much do a brute force against that and gain access to all the data on that server. Alright, so that's Nikto in a nutshell. I'm now quickly going to just talk about NS lookup. Okay, so let's quickly talk about NS lookup. So let's clear the screen. And NS lookup is basically a command line tool to do DNS lookups. It's very, very useful, and a quick way to quickly check things. So let's just see NS lookup for cnn.com as an example. We'll give you the IP address of cnn.com. The nice thing about NS lookup is that you can also go into interactive mode by just typing NS lookup, and then you can literally set the type of the MX records that you are looking, or sorry, the type of the DNS records. So let's just say we're looking for only the A records. So we set type to A, and then let's quickly query that thundercloud.co.za test environment that we used in the footprinting phase. As you can see, it brings back that 52 IP. However, if I set the type to MX and type the exact same command, or sorry, the exact same domain, it'll bring back only the MX records. So this is very, very useful down the line, but tools like DNS enum and DNS Recon do this automatically for you. What I did want to show you, however, is that if you type help in Kali Linux or any Linux OS, it will tell you the help command is not yet implemented. And there's a very useful command to do a zone transfer. So if people haven't configured the DNS service properly and you can do a zone transfer, it's a very quick way of pulling every single DNS record about a domain. And the command is ls-d. And as you can see, it's also not implemented in Kali Linux. However, let me quickly show you on a Windows machine. So on a Windows machine, I can do NSLOOKUP. It's exactly the same, uses exactly the same commands. But when I type help in here, I get the full list of features that come with NSLOOKUP. And these features work on Kali Linux. So if you have access to a Windows machine, this would be a great way to actually find all the different options that you can set. And the ls-d command does work here. So let's try that, ls-d, and let's put in that domain name, thundercloud.co.za, and as you can see, the DNS is configured correctly because the zone transfer security settings did not allow it to go past. And that pretty much concludes this video on scanning. I hope you found it useful, and thank you for watching.